Welcome to our talk on java.nia.file for remote systems. Before we start off, let's first introduce ourselves. I'm Jeroen van Erp, reachable on Twitter at HereKnows, and I work for XebiaLabs.
Yeah, and I'm the other guy. I'm Vincent Partington. I also work for XebiaLabs. I've been working with Java for since 1.0 or something. 95, been doing lots of performance stuff, middleware, lots of development, and now I've been working on this and more. And of course, we work for XebiaLabs. This is the plug, this is the marketing slide. Our company is headquartered in Boston. We're from Holland, actually, from one of the development offices there. And we build a deployment automation product for java.net platforms. And what we did here, actually the thing we're going to talk about actually came out of this. It's a component of the product we built here.
So let's, before we start off with the real subject of our talk, let's do a quick recap of what java.nia.file exactly is. Basically it consists of three classes, interfaces, java.nia.file path, files, and the FileSystemProvider. Those are the three main components, of which path and FileSystemProvider are... path is an interface, and FileSystemProvider is an abstract class. And basically the goal for .nia.file was to make it more abstract. The old java.nia.file was pretty deep down file, and make it more modular. So if we look at the path interface, it has a lot of methods which actually deal with paths, but not with files. A path is not necessarily a file. There's still a difference there. And one of the main things here in path is once you construct it, it's immutable. So how do you use a path? Well, you get one from a file system. And for instance, my home dir, that's actually my home dir on this Mac. Well, actually not on this Mac, because this is Vincent's Mac. But you can also get a path to something that does not exist.
Yeah, and actually also, you can also construct partial paths. So it doesn't even have to signify an actual home blah blah. You just have could even be path. Then you can concatenate them.
So then the files class is basically, it deals with translating paths to files. And it uses, you can use it to actually static import, and you can just do copy path from path to path, create a file, add a path using specific attributes, etc. And for instance here, a copy operation of etc hosts to a text file in my home directory, and it will overwrite the destination if it exists. So the main thing you actually have to implement when you're implementing a new .nia.file functionality is FileSystemProvider. And that's actually the service provider interface for the Java services service provider parts. And the main thing it links up to is actually the URI scheme. The standard one is file : ///, but you can extend that to other ones. That's what we're going to show actually in this talk. So let's get to our first demo. This is a scenario which we actually comes from the deployment automation world, of course. That's what we work in. We copy a Glassfish server zip to a machine. In this case, the local machine, because we're doing old plain Neo. Unzip it, start the server, copy a pet clinic here, so actually deploy it to the server, show the log file in the console, and then afterwards clean it up, of course. So how does that look if you look at a plain old Neo file? So first we copy the Glassfish zip. What we saw in the presentation is just a standard files.copy of a path to a path. Unzip it. We've actually defined a lot of variables here, which we actually override in all our other scenarios, which we fill in. Unzip it. We start a process on our local machine. Now we start the Glassfish container, start another process, but a long-running one in this case, because we want to keep it running while we actually deploy it. Then we copy the pet clinic here. Afterwards we stop and clean up. So basically, how does this work if we actually do a java.nia.file? We just get the default file system and set the target copy path to temp. And unzip is called unzip on Unix or Mac systems. So and if we run that one, we can actually see that this just works. So it's now copying it over. Did I start the correct one? So we're waiting until it's up. We're deploying the pet clinic here. So pet clinic is now deployed. We see the dog and cat. So let's terminate it so that it can clean up. And we'll actually show you that it's really also cleaned up, because the URL is no longer reachable. So, basic scenario, but okay, what was the problem we're trying to solve? We work for a deployment automation company, and one of the key things, of course, is in deployments is that you probably don't run them on your local laptop or local machine. You need to get them out there to the cloud, to another machine somewhere. And java.nia.file is not suited for that, because it's basically the only implementation you get for free from Oracle, is the local part. Just file colon //. How do you go to a remote system? Luckily, all is URIs, so we can do that.
So we started this project over there, we called it. It's a utopia in our view. We started about 4 years ago. Back then, NeoFile wasn't out there, so we actually started building a solution based on the Java.nia.file and Java.lang process. The problem with those two is that they're actual classes, so they're impossible to extend. So we basically defined our own interfaces and called Overthere file, Overthere process, which are kind of similar to Java.nia.file and Java.lang process, but they're interfaces. And we changed one of the nasty things in Java.nia.file, that if you can count delete a file, you get false back from the delete function. Now we just throw exceptions. But other than that, the whole spirit is basically the same. So they're interfaces. We added an SPI to be able to add our own implementation and to then access remote systems. And the main use case was actually to do, we started out with support for Unix, so it was SSH with SFTP and all those different kind of flavors of that, but we'll get into that later. And later we added support for Windows. This was all very nice, working very well for us. But now that Neo 2 came out, we thought, hey, we can do the same thing, but then in Neo, and then actually make it look even more like official Java. So we actually built something called Neo Overthere, which is a layer on top of Overthere, which has an Overthere FileSystemProvider, our own path implementation. And that's the thing that's kind of lacking in the whole Neo abstraction, at least for our use case, is a way to also abstract processes. Because also there you want to do remote processors or local, different ways to spawn processes. So kind of comparable to the files class that Jeroen showed a few slides ago, we added a processes class where you can start processes and execute commands and this kind of stuff. So that's what we started building, and that's what we'll show. I saw there was one demo still running. Can kill that one. So what I'll show first, is actually, I think I already said all of this. Basically the same demo we just did, but now using our wrapper and our nicer process abstraction. So the way it looks is So we first extend the scenario class, because if you remember here, you saw a lot of stuff like this going on, process builders and getting the output and going over everything. And now we have our process abstraction, so we actually override methods like start glassfish container with our own interface. And for example, unzipping a file is actually a lot simpler, because here you can just say processes.execute, and it will just run the command in blocking. So this method will only finish when the command is finished, which is fine for zips, for unzip command, but for example for glassfish, we still get a similar kind of start the process, keep it running, and later shut it down. Yeah. So I run that. I'll first show you there was nothing there, as you already showed us. And I can basically show you, do kind of the same thing here also, the setup. The only thing is that instead of using file : // I use local, which is our way of saying local access. And then I just read it. And it should do the same thing as we just saw. So just copying over the zip, unzipping it, starting glassfish, copying the error. This is a log file coming out. And then when it's done, it should show me the link where I can go, which is this one, which is now running. And I can kill it again. Well, now you're wondering, what's the fun? You just already did that with Neo, but now we can actually improve on this by actually adding other URL schemes. We'll go into that.
Yeah. So the first thing we actually added was SSH, because a lot of systems we deploy to our Unix systems, and basically the main way to go in there is a secure shell. So basically we can do secure file transfers and command executions. So what we did is we actually found this library by a guy called Shakar, which is SSHJ, and we actually embedded that into Overthere. So it has quite a lot of functionality already. It has an SCP and SFTP, so secure copy and secure file transfer. It does all kinds of authentications like interactive auth, password, and public key. And it has support for tunnels, which in large enterprise environments actually comes in quite handy, because there are firewalls and DMZs which you have to go through. So you might need to jump to one or two machines before you actually reach your target machine. So all of this is actually also exposed in Overthere and in Neo Overthere, and of course in our product then. So let's first show the SSH and SFTP thing. As you see, we've identified a URI scheme, SSH plus SFTP. And the only thing we actually changed from this demo to local to the next one is that we actually connect through another URI scheme using a username password combination. And we provided the operating system. We actually have quite a lot of options which you can pass either in the URL or in the map, in the options map, which you pass into the file systems class. Those are all explained in Overthere. And one of the main things there is the operating system, because for translating files, you actually need to know whether it's / or /, or whether you have a drive letter in front of it or not. So this is the only thing that's actually changed. And now Vincent has at least one image running on his MacBook, which runs Unix, and which has these credentials set up. So let's run it to see whether it works. So it's now copying it over the network, but it takes slightly longer than local, of course, because it has to go through to an image over SSH, and that's encryption takes some time. So it's deployed. Yeah, it's really there. It's on the Overthere host, which is not this machine, but the other one. Where you have it. So let's see whether it's really there in this machine. Yeah, it's got the zip and the glassfish directory there.
You can do a PS.
Oh, we can do a PS, of course. It's PS CIFS. We see the SFTP server. Where's my mouse? Is of course not working. We see the SFTP server actually running a Java process on the glassfish path. So if we now switch back and terminate it, so we're all done. Nothing's there anymore. So we actually really interfaced with this machine. Now, one of the parts you also need in the deployment automation and in SSH library is support for actually different users, and sometimes also run as or the do as command called sudo. So it's for those intimate with xkcd. This is always a nice joke. Your wife might not take kindly to this when you try this at home. So, but basically what Overthere can now do with sudo support also is that we can transfer files with the correct ownership. So you have both the connecting user and the actual owning user. So the files that are transferred are actually transferred as the user that will own the files and not as the connecting user. And you can do sudo in two ways. You can either do it in a no password setup or actually in an interactive setup where you get asked for the password. So Overthere has support for responding to the sudo password prompts. So we've got another URI scheme for that called SSH plus sudo or SSH plus interactive sudo. We'll just show the sudo one. That also contains a private key authentication. So we actually wanted to do some nice things. So we actually put a private key in the option map, pass it into the file system again. So you see a sudo username here also, called Overthere, and the connecting user is called trusted. And when we run this, we actually again see the same scenario running. There it is. So when you a bit too fast. Wanted to show you that it was actually executing command with sudo. Well, we can show on the machine. So it's running. Let's first show the machine very quickly. PSAXF. We actually now see it sudoing as Overthere. So that's in between there. And we can of course show again that it's running. So, but what about Windows? Because that's of course a whole different system.
Yeah, so I guess that's me. Yeah, the thing with Windows is that there is SSH available. There's WinSSH, OpenSSH. There's a few different ways which people build SSH support for Windows, but none of them are really nice. OpenSSH is hard to install. There used to be a Norwegian one that was easy to install, but now it's commercial. WinSSH is commercial, and all of the slightly different ways in which they encode the path of the commands. It's just not exactly natural way to do remoting on Windows. Of course, there's RDP, but that's impossible to execute commands automatically. But luckily, there's a few different technologies to do stuff remotely in Windows boxes. To access files, basically use CIFS or SNB, as it's also known, to copy files. And then to execute commands, there's basically two options. There's Telnet and there's WinRM. And let's first go into CIFS. So for CIFS, we use a JCIFS library, which is built by the same guys that built Samba, so they know a bit or two about the whole protocol. And we support local accounts and domain accounts using NTLM. So that's we actually get that for free by using JCIFS. But there's no remote execution with CIFS. That's just copying. So that was easy, but then the hard part was actually getting the remote execution bit in. So we started with doing Telnet. Telnet is always there on the Windows box, even with pretty old versions. You have to enable it, of course, but there's two big caveats there. It's not secure. Admins don't like it, and to actually automate it, we have to do a lot of nasty screen scraping. You just get a login prompt and have to respond to the login prompt. Kind of similar to the interactive sudo stuff we have to do. Send over the password and then send over a command and then wait until we see the Windows prompt appear again at the end and then echo the error level to get it out. It's pretty nasty. It works, but it's not our favorite. Well, to show you that it works, let's first demo it. And you can actually see a lot of Telnet prompts come by because they're even hard to filter. So let's hope my Windows box didn't change its IP. No, still the 130. So I have this setup. So again, kind of similar to the other ones. But now I have here CIFS plus Telnet as my scheme. And I log in as an administrator, being a typical Windows user here. Bad. And then I copy to ctemp, and I also put an unzip exit there. And then I turn this one. And we'll do exactly the same thing we just saw, but then on a Windows machine. So it's copying the zip, and then let's see. Yeah, you saw them. Stop doing that. Here you see the Windows Telnet prompts come by, and you even get the Microsoft Telnet server banner appear in the log. So it's not very nice, but it should work. Of course, I should have done this. And there it's up. So I can click the link here. Then I have the whole Glassfish running expanded with the pet clinic here in there on the Windows box. So it's again the same code, but now with a different parameter. And the only thing I really had to change was the location and the unzip.exe. It's kind of a pity that they're different on different platforms. But as I said, it's not a very nice way to do remoting on Windows. So we also added another way, and that's WinRM. And are people familiar with WinRM? Windows admins. It's been in there since 2008 R1, I think, and you can even have it in older versions. It's actually a pretty nice way to do remoting on Windows. It's pretty well linked up with the whole PowerShell way of doing executing scripts on Windows, the nicer way compared to command to batch files. It's Microsoft implementation of WS management. You can run it over HTTP or HTTPS, and you can use basic authentication to authenticate local users or Kerberos for domain users. And the only thing we don't support yet that's part of WinRM is XML encryption, just because it's a big hassle to implement. I think we'll have to do it at some point, but any pull requests are welcome for that part. We have a code on GitHub. I'll send you the link at the end. So, but again, it looks the same to the user. So basically what I can do, so in the 6th demo, do a run as. Let me check those. Let's see. And now at the top you don't no longer see the Telnet prompts appear because now it's nice WinRM. It's just a proper remoting system. And you just see the actual logs of what we've been executing. And you see here it's WinRM client flash by. And I can click the link. And again, I've got the same thing deployed. I can terminate it and it will now clean up everything. So, what we've now seen is actually that we can do the remoting over all these different protocols without even changing much of our code. It's just the settings that change, and that was actually quite nice. But we've also learned a bit or two about Neo.
Yeah,
And pass it on to you.
definitely.
Yeah.
Well, Neo in itself, the plain old Java Neo, is very easy to use. It's a bit more abstract than java.nia.file, the old files, but it's easy to use. Actually, it makes for a nice API, and you can implement it. And it's you couldn't do that with File. With File, we actually had to build it on top of it. Now we can actually build it under it. So the user just drop in a jar, and you actually have access to a whole slew of other protocols there. So the only thing that we thought was missing is actually a process abstraction, because executing local processes, process builder or system.exe, what is it, system.exec? No?
Runtime.
Runtime.exec. You can only execute those processes locally. But you want to do that also remotely through a same kind of API, actually not knowing on the top level where it's going, all the implementation details of executing that process, but also doing that. The whole thing with the URI schemes is actually very nice. It gives you that abstraction. You can configure a URI somewhere in a properties file, and you can go in your application. Just, you don't care when you write your code where it all is going. You can configure it actually instead of writing it out. The file system provider, that's actually the only state in the whole implementation which you need to keep around. It needs to keep around, for us, a connection, for instance. So you should also close a file system provider after you're done with it. Only trick here is if you try that with a default file system provider, it'll throw an exception. So they haven't actually made it check somewhere, or actually made it silently ignore it if you try to close it. It will actually throw an exception, so you have to be careful there and check whether you're actually using a local file system provider or a remote one which actually needs to keep the connections alive. The only thing that was actually the case is it's quite a lot of implementation work. Path itself is an interface, and if you look, for instance, in the OpenJDK code, there's quite a lot of implementation in there, and you need to write that all yourself again. In this case, a lot of code actually looks quite the same for different kinds of paths, but there's no sharing. Everything is made package private or even private, or deep down in ComSun internal, or so you actually have to write it all yourself. Yeah, of course you can copy and modify, but then you don't have a test. Sorry. It's actually GPL with a compatible open source exception. Like MySQL has the floss exception. So any open source project can use it. Any commercial competitor of our product cannot use it, at least not without paying a license fee. Yeah.
What happens to the processes if you disconnect? Because you were showing a demo, you could see a SSH process and spawn something. What happens if you disconnect with SSH? Does that process stay around or does it die?
Yeah, well, actually, in the case of SSH and Unix, you can keep the process alive, of course, by using a no-hub. But what we did is actually, because we also wanted to run the same code on Windows. On Windows, once you disconnect from the connection, it actually also drops the Glassfish process on the floor. So your process is gone. So we couldn't demo that. So that's why we actually kept the connection open. But on Unix systems, it's no problem to actually start a long-running process there and keep that running while your laptop disconnects.
So then the second question, if you do start it with no hub, how do you come back to clean it up later?
Well,
Where it is?
in the case of our demo, it's easy because you actually have a command line client. You can call start domain and stop domain. In other ways, you can actually, what you normally have is actually you cut the process ID into a file and you read that back out later and actually connect to it again.
So does your framework provide this sort of abstraction?
No.
Actually, this is something we're just talking about with some guys from Rundeck, about how we could support long-running processes. Because in SSH, like you could do a no-hub, but then it's hard to get back to that process. WinRM is actually pretty nice because you can actually detach from a shell, and then if you keep the ID around, later attach to the same shell. So, but kind of wondering still trying to figure out how we could make it work for both. And then Telnet, well, I think we just have to give up on that one because I don't see that working. So it's basically running a command in atomically, which is the execute one. And we support running one for longer, but not for longer than your Java process. And the third we're now trying to add is for longer than your Java process and the later attaching, which is what you want, I think. That's
So to use your stuff, it's basically just a library?
Yeah.
Okay. So if you were to do something like, where you had to actually take out the current server before you wasn't doing, you could add it to your program, your library?
Yeah. And basically what our deployment automation product actually also does. It's actually doing quite a lot of that stuff.
You guys have anything available as like a Maven plugin?
Sorry.
Do you have anything available like a Maven plugin so that the build and deploy process would be automated?
Not for Overthere itself.
Yeah, our conversion product, we have a Maven plugin that links into our server and does stuff, but does a lot more than this. Overthere itself, it's just a Java library. And I know the JClouds guys are building something on top of that, but that's more the cloud space. But for us, it's more, you just basically get abstraction of Java stuff, and then it's up to you to build something around it. But,
It should be possible to write a Maven plugin around it.
a bit like Cargo, I would guess. Modern.
A wagon.
A wagon.
So basically what the Overthere's Neo's interface, Overthere's Neo interface allows you to write remote management code that's portable not across source platforms, but also across target platforms. And well, to paraphrase the Java line, write once, run against anything, instead of run anywhere. So we can actually run against any hardware, where it is, we don't care. So more information. We have actually we have a bit more open source projects on GitHub, but these are the two we actually showed you today. It's Overthere and Neo Overthere. And as we said, pull requests are welcome. If you start using it, let us know. Awesome to connect. And our calling cards.
So any questions? There. Oh, yes.
Sorry, I couldn't hear it.
You probably said answered this question you said it earlier, but I came a bit late. So I was wondering which protocols are supported. I saw CIFS and probably
yes. Okay, so the question was which protocols are supported. Well, basically we support SSH with SCP and SFTP for file transfer, so secure copy, secure file transfer. We support CIFS as the file management API with Telnet and WinRM as the execution models and underlying protocols. And local. Did we add anything else? No.
That's it.
No, that's it. So basically, Unix and Windows systems are covered using the most frequently used APIs.
And the SSH client is implemented in Java, or do you at some point?
Yes, no, actually the SSH client, it's a SSHJ library built by a guy called Shikar. It's on GitHub also. And we actually embedded that into Overthere.
Yeah, they're all native. So also the WinRM client is also a native client. So it's also
Everything is in Java.
And since you implemented it over NIO, again, so the client system that would say potentially connect to multiple servers to push bits and stuff, it's going to work with a much lower concurrency than the total number of machines we want to push to, right? So we're going to be more efficient using of threads because we're using NIO.
Did you get a question?
what's the
Well, what I want to say was one of the cool things about using an NIO subsystem in your server, at least, if you're using that, is that you can actually scale to a significantly larger number of clients. The server is significantly larger number of clients than you would if you used a traditional blocking model. So I was just wondering if the same advantages apply to your
Yes, I think I get you. So the question was, I think, if you use NIO, actually, is it all non-blocking operations? Well, we don't use the NIO streaming part. It's only the NIO file library here, and that's actually, it doesn't really have to do with all the NIO buffers, etc.
Okay.
Yeah, those are actually two decoupled parts. All the buffers, etc., that's NIO, and the file API was actually called NIO.2. So it's actually another part of that same new IO library in Java.
I'm doing streaming over these remote things, or just doesn't always work. You just get the whole blob. You have to handle it. So we didn't actually do random access stuff yet. We just basically push a file, get a file. So it's more in that respect.
You also support like read-only files, for example, over HTTP or WebDAV or read-write over.
No, not yet. No.
I think it's something that if I want to add more protocol, it's not relatively easy or.
Yeah. It's pretty easy actually to add more protocols. The question was, do we support HTTP, WebDAV, etc.? And if not, how easy is it to extend it? Well, it's pretty easy. For over there, it's just you implement what is it?
Yeah.
Overthere
file and
Overthere process. Well, for process, it doesn't really make sense for WebDAV or HTTP because you can't do process execution. But that's mainly copying files over. That's pretty easy to extend. You annotate your class with an add protocol annotation, then it gets automatically picked up in the Overthere library and you can use it. Yes, class path scanning. Yes.
I think
Because I was thinking, like, for example, in the Unix and the Linux desktop environment, they work quite a while to let me say here or no, for example, they have these file managers that support any protocol, like Nautilus and
Yes.
Opera.
Yeah.
So it sounds like with this technology, it would be relatively simple to write a file manager in Java that is just support all these protocols while you work.
Yeah, so actually the question is in a lot of operating systems, your file manager can actually connect to a plethora of different systems using different protocols. Except Windows. So Linux, Mac OS in this case. And would that be easy to implement actually now with Java? Yeah, I think it would. We already made quite a large step towards that using Overthere. We don't, as we said, we don't support HTTP WebDAV yet, but send a pull request.
And are they, do you know any projects that try that?
No.
well, there's Apache Commons DFS, which is kind of similar, but they focus more on file stores, but execution is not part of it. So that's actually when we started out with this 4 years ago. Commons VFS was kind of dead, now started up again. But they're more focused on HTTP, WebDAV, temp files, that kind of stuff. And execution is not part of the deal. And for us, the use case was not about storing files or accessing them. It's about doing remote systems management, deployment, provisioning, that kind of stuff. So that's why we focused on all the ones that allow you to do copying files and then executing commands. The focus of both projects is slightly different. It would be actually cool to talk with the guys because I think we're kind of doing the same things. And probably if you would wrap commons VFS under NIO, as we've done here, then you could basically just switch between schemes and go from VFS to Overthere without even noticing. Just go through the NIO to file abstraction. It's actually good. Write it down. Yeah.
Yeah, well, basically, of course, macOS supports SSH when it's a remote system, or when it's your local system, it supports local processes which are already in Java, so yes. You just have to open up your SSH daemon for that, but that shouldn't really be a problem. I think that's one checkbox. No more questions? Okay. Oh, sorry. Slide 4, yeah, sure. So, that's it for us. Thank you for listening to us.
Yeah. Thank you. Bye.